And here we are at section 1.3a. 1.3a. Section 1.3 I split into two parts. 1.3a we're really going to do the distance formula in Pythag, Pythagorean Theorem, for those of you not in the know. And then 1.3b we'll talk about the midpoint formulas. So what we're going to do is we're going to use coordinate planes. Everybody's familiar with coordinate planes. You've all graphed before, right? They're pieces of graph paper. But a coordinate plane is an XY axis, and then you can plot points. So here's the important part. On a coordinate plane, you can use the Pythagorean theorem if you like Pythag, or you can use the distance formula to find the distance between 2 points. It is personal preference. I am not going to tell you which one you do or do not have to use. Some of you are going to like one way or the other. Some of you are going to like one way depending on how I give you the problem. So just a quick run through of Pythag. So Pythagorean theorem review. First of all, it only works for right triangles. So I've got this little triangle on the side. I need to make sure that I know that it's a 90-degree angle. Crucial. The second thing that you need to make sure you recognize is that in Pythagorean theorem, A and B are legs. The legs form the right angle. So this is a leg and this is a leg. And it doesn't matter which way you name them. A can go here, B can go here, or you could switch them. And the other important part then, the third side of that triangle, you may remember, is the hypotenuse. It is straight across or opposite from the right angle. So this would be C. Notice that right angle kind of points at the hypotenuse. If you can identify the legs A and B and the hypotenuse C, you will probably already know that A squared plus B squared equals C squared. So take the two legs and square them and add them up. That will give you this hypotenuse squared. Again, remember, this is recorded, so if you need to stop, pause, back up, rewind, rewatch, please do so. So let's talk about this. So if I give you a problem like number 1, find the distance between K and L using the Pythagorean theorem. I'm telling you what to use because I want you to see what it looks like. You might not like this, but that's all right. We can do it one time and endure it. So the first thing I'm going to ask you to do is to plot K and L. K is at -2, 0. Everybody remembers it's X first and Y second, right? So back to -2, up 0. Please put the point, think back to section 1.1. Points, lines, and planes. K is a point, capital letter K. L is at over 1, up 4. What I'm asking you to do is find the distance between those 2 points. So if we're going to use Pythagorean theorem, A squared plus B squared equals C squared. It looks to me like that slanted side, KL, is C, is the hypotenuse. We need some legs. So what I'm going to do is I'm going to draw straight down from L and straight across from K. That forms myself a right angle. And then I just need to know that my 2 legs are those sides that I drew in. I'm going to use the graph to count them to find the actual length of side A and side B. It looks like 1, 2, 3. Everybody agree that that one side is 3. And it looks like this one is 1, 2, 3, 4. If you're not sure where those numbers came from, make sure you ask. So if I know that A squared plus B squared equals C squared, I labeled A as 3. You could switch it. It doesn't matter to me. So either 3 squared plus 4 squared or 4 squared plus 3 squared. I'm going to leave it as a C. If you want to use an X there, go ahead and do that. So this is a nice, neat, very simple answer because we don't have to deal with any decimals. So 3 squared is 9. 4 squared is 16. Remember PEMDAS. You are going to do exponents, squaring, before you do addition. A lot of people try to do 3 plus 4 is 7 and then square it. Do your 3 squared and add your 4 squared. So 9 plus 16 equals C squared. I think that's a 25 equals C squared. Is the length of KL 25? No, that's squared, right? How do you undo a squared? What do we do to get an actual answer? Square root that. So that means that C is equal to 5. So the length between K and L is 5 units long. They don't all come out nice and neat and perfect like that. Sometimes they come out to ugly answers like 4.7. We're going to do some rounding. We'll go to the nearest hundredth. We'll talk about that in just a second. So I like to use Pythag if stuff is already graphed for me. I think that makes it easier, right? If it's pre-graphed, I can just make myself a little triangle, figure out A and B, and go from there. However, things aren't always graphed, or sometimes the numbers are ridiculous, like point K might be at negative 2248. Well, I don't want to graph that. That seems like a really long way. So our alternative is to use the distance formula. Hopefully everybody remembers the distance formula. So the distance d between 2 points with coordinates. So my first point has an x and a y. My second point has an x and a y. Here's the formula. Make sure you get it right. I tried to make it big so you could see it. D for distance is equal to a giant square root. Remember, we square rooted when we did the Pythag too, right? So square rooting is nothing crazy. We're going to subtract our x's, so x2 minus x1, and then square that answer. And then we're going to add to that, subtract the y's, y2 minus y1 squared. So let's do an example. Let's make sure that you can see what that looks like. I'm going to turn my page so I won't have my distance formula there. However, you still have yours written down, so I can write that real quick. So it says find the distance between the points using the distance formula. So in other words, I'm asking from this point to here, how far is that? What's the distance on this coordinate plane? So my distance formula, subtract the x's and square them, plus subtract the y's and square them. So it's a plus in the middle, minuses in the two parentheses. So here, it doesn't matter which one's your first point or your second point. So here's an x and a y from my first point. I label it x1 and y1. Here's an x and a y from my second point. The biggest mistake people make is they rush and mix up their x's and y's and they're subtracting. So take a minute, take a breath. So I'm going to set up my problem so I can just put some numbers in there. So x2 minus x1, so it looks like it's a 3 minus a negative 5. You might have learned chum chum somewhere along the way. We can deal with that in a second. And then subtract the y, so it looks like it's a 2 minus 6. Please remember it's a subtraction inside those parentheses, no matter what your signs are. So 3 minus negative 5 ends up being, right, an 8 squared. 2 minus 6 ends up being a negative 4 squared. So that's going to be a square root of 64. Remember, square before you add. Hey, big question for you. What's negative 4 squared? I know it's 16, but is it positive or negative 16? I want everybody to hear me loud and clear say when you square a negative number, the answer is always positive, no matter what. So negative 4 times negative 4, because that's what squaring is, right, is 16 positive. You will never subtract inside that radical for that last step. So let's see, 64 plus 16, I believe that's 80. If I go to my calculator and do a square root of 80, that's going to come out to an 8 point something, 8.94 is the approximately the distance. Oh, I thought I had segment or points up there. So make yourself a little note. Round to the nearest hundredth. 2 numbers after the decimal. If everybody's rounding the same, we won't have any kind of issue. So round to the nearest hundredth. So the length of that is 8.94 units. So almost 9 units long between those 2 points. So I like to use distance formula if I'm just given 2 points, no picture. I like to use Pythag if I'm given a picture and it's already graphed for me. I can easily put in a triangle. So I think that should be good, right? I don't know that we need to do any more examples. I do want to say this right here, right at the bottom. From here on, you can use the distance formula or Pythag, whichever one works best for you, or you can switch back and forth between them. As long as I see your work, I will know what you're doing. So your choice, just know how to find the distance between 2 points on a coordinate plane. That is it for section 1-3A, and I will see you next time. Bring your questions with you.